So, I am thrilled to introduce to you today's keynote speaker, Dr. Nergis Mavalvala. Nergis is a physicist. Is there music on? Oh. When you said vamp before in my other notes, I thought now I have to dance or something. All right. No. It's like really Lane from Seinfeld. Nergis is a physicist whose research links the world of quantum mechanics, usually apparent only at the atomic scale, with some of the most powerful yet elusive forces in the cosmos. I just read what's written. I almost read it as yet evil forces in the cosmos, but it's elusive. She received a BA from Wellesley College in 1990 and a PhD from the Massachusetts Institute of Technology in 1997. Nergis then went on to become a postdoctoral fellow and research scientist at the California Institute of Technology between 1997 and 2002. Since 2002, she has been on the physics faculty at the Massachusetts Institute of Technology, where she is now a professor of physics, and I love this, a recipient of a MacArthur Genius Award. Yeah. In her spare time, from what I think of reading, this isn't too much, she loves to bicycle long distances, play squash, and hang out with her 4-year-old son, Evan, and I'm still waiting to see pictures because he sounds like a doll. So please join me in giving a very warm welcome to the 2012 Out to Innovate keynote speaker, Dr. Nergis Mavalvala.
So hello everyone and welcome. I hope you've had a good lunch, and if you haven't, please feel free to go ahead. I'm not so sure I'll have all that much exciting to say. But let me start by thanking the organizers, Amy Ross, Shelley Diamond, and so many others who've put this together, to all of you for being here. And I would like to spend some time today talking to you a little bit about being out in STEM from my perspective. So this is a keynote talk, so I felt like I should strike a keynote. And so here is the keynote that I want to strike. And I want to talk about sort of my experiences and some of the things you might find sort of helpful or interesting in the spirit of difference and risk. So the two messages that I have, these are sort of the principles that have really helped me in my life and my career. The first is to celebrate being different. We're all different, not just because we're queer and we're nerds, but we're different in many other ways too, okay? And so celebrate that difference and surround yourselves. We all should surround ourselves by people who can embrace our differences. So that's my first keynote. And my second keynote is to take risks, because it's often really worth it. And since we're all scientists or technical folks of some sort, we usually know how to calculate. So the message here is to take calculated risks, okay? And so with those two themes in mind, I want to talk a little bit about how those have worked together in my life. Is there a little echo? Should I step back here? Oh, bring it down. All right, is that better? All right, very good. Thank you. Okay, so I wanted to start just by sharing with you a little bit the journey of my life and how difference and risk have sort of come together in that. So I was born and raised in Pakistan, and most people until about 7 or 8 years ago hardly knew where that was. Now it's on the world stage, usually in a relatively negative light. Mostly when I was growing up, it was actually an okay place. And it was, even when I was growing up, starting to have some of the, what you call seeds of religious extremism, which is very much so in place now. But when I was a kid, I was a little different. And in the most noticeable way, was a little gender bending. And in a traditional society, that didn't always work too well. So I grew up with short hair and wearing jeans and T-shirts. I grew up in a very big city. And the bus system, when I was growing up, I don't know if it's still true, it probably is, was segregated. And what that meant was the women had the front section of the bus with a physical barrier, and the men were in the back section of the bus. So I was around 12, 13 years old, and as I was used to doing, I boarded a bus, and the bus driver, being in the front section, roared at me, "Get in the back at once, how dare you come into the women's section?" And I didn't take much to convince him that this was okay. As soon as I opened my mouth, he was like, "Oh, I'm sorry, you know, all right, come on in. But what are you doing dressed like that?" Okay. So I grew up in that kind of milieu of being slightly different in the gender-bending way in this society. And one of the messages I want to bring out is when we are different, we should surround ourselves by people who understand and are supportive. And it turns out, amazingly, my family rather was. They had no concept at the time of anything but tomboyism, as opposed to, oh, this could be the, baby dyke in the making. But they were supportive, and they kind of, to the degree that they could and let me still survive in that society, they would ply me with my male cousins' hand-me-down clothes, etc. And so I did make it through. The other way in which my difference was apparent was I was a nerd from pretty young on. Again, something that I had no other way of being. I didn't know any other way to be. And luckily for me, that was not so unusual, so I ended up in a cohort in my school that were kind of like that, and that worked out. So again, finding people who could help you be the way you needed to be, that was sort of the thing that worked for me. So this lesson sort of carried on with me, so I came to the United States to go to college. I was an undergraduate at Wellesley College, which was a fantastic experience for me because it was a women's college, and it was also a place, this was in the late 1980s. I was there from 86 to 90. It was a place where being unusual, being a lesbian, being a woman, certainly was quite normal. So being a woman at a women's college was indeed normal. And so it was a very great experience for me to be part of people who I felt were kindred spirits. I want to talk a little bit now about that, my science career, because it sort of weaves in with my story. So whilst I was at Wellesley, I learned, I was a physics major right from the start. So one of the things that people might find curious is, so I went to a high school when I was still in Pakistan, where very early on, by 7th grade, we get tracked for whether you're going to be a science math type. So there were 3 things you could choose when you were in 7th grade, I believe. You could choose to be on the science math track. You could choose to be on the literature and classics track, or you could choose to be on the finance and business track. So imagine that. By 7th grade, you were tracked, and most people then continued in those areas. So when I was choosing college, I kind of felt like, okay, I've already done science and math a great deal. It would be kind of interesting to learn a little bit more about the classics and philosophy and literature, the things that I hadn't really gotten to do in as much depth in high school. So I chose to go to a liberal arts college. But the truth was I was still a nerd. And so I did physics and astronomy there. That's what I studied. And very early on, I became involved in laboratory research. So all 3 of my summers of my undergraduate years, I worked in a lab. And there I also learned to take some scientific risks. So one of my very early projects was I was working in a lab that had a laser. And my advisor, who I know well to this day and adore, suggested after a few weeks that we'd been working that the laser wasn't working so well, so maybe I should clean the mirrors. Now, this was a homemade laser, so most of us are very used to a commercial laser, and you have a service contract and you send it out. This was a homemade laser, which I hadn't made, but it was my task to clean the mirrors. So I dutifully took the whole laser apart, I cleaned the mirrors, but very quickly realized that that was not the way to do it. A laser is very hard to align, so you should take one mirror out at a time, clean it, put it back, align it, and here all 4 mirrors were out, and I had no idea what to do. That was some risk. So the moral of the story is it's good to be fearless, but not good to be foolish. Okay, so balance of those two things is important. Eventually, we got the laser put back together and working. Not long after that, I built an electronic circuit, and I used at the time what felt like an enormously expensive thing. This was $100 of a power op-amp. So for those of you who know circuits, a $100 chip is a pretty unusual thing because they usually are pennies. So I built this circuit, and of course, the moment I plugged it in, smoke and my $100 chip was gone. And so now I was too, had just barely gotten over the laser fiasco. How was I going to go tell my advisor that I had blown this chip? So I did something that at the time felt very courageous to me. I called up Apex, who is the chip maker, and I said, well, I'm just an undergraduate, and I work in this lab, and I have this chip, and I wired it wrong, and it doesn't work anymore. Can you tell me what to do? So he asked, the guy at the other end, technical support, asked me what I did. I said, I wired the plus and minus 200 volts backwards. So, so he says, I think that chip is history. So I was like, well, what can I do? So he said, well, you'll have to replace it. I said, could you send me a couple of samples? And amazingly, a few days later, 5 chips came in the mail. So the moral of this story, of course, is take risk. It's okay sometimes if you're foolish, but then you still got to fix the mess. Be brave. Okay, so my science career is sort of filled with stories like this of taking risks, and some of them working out, and sometimes they don't. So I finished college, and right away, I think like 2 days after I went to my commencement, I started graduate school, and this was at MIT. And one of the things that happened, I've been working in the field that I work in, the thing that Amy so appropriately called the most evil things in the universe. So I'll tell you a little bit about these evil things in the universe. It turns out I do study rather evil things. What I work on is I look for gravity from stars instead of looking for light. So when we look out into the distant universe, everything we do, or most things we do, is we collect light. Now we know that there's a bunch of things out there in the sky that don't emit light, or at least not usefully enough for us to be able to detect. These are dark objects. Black holes are an example of that, where they have so much gravity that the light can't escape from them. So the other thing we know about these objects that don't emit light is they do have mass, and mass means they must have some gravity. So the thing I work on is something where we go out looking for gravitational waves from sources out in the sky. So this isn't just of heavy objects sitting in the sky and we look for little bits of gravity. These objects are whizzing around in space, and because they're whizzing around, they're actually emanating waves, ripples that are traveling towards us due to their gravity. They're emanating these ripples because around the place where these massive objects sit, the whole space-time is very warped. So let me give you some idea, and this is sort of a fun thing that I think even non-physicists might have fun carrying away. So Newton was the first person to really understand gravity, and everybody has heard of Newton's law. Newton said there is an object here and an object there, and they feel the force of gravity, which is an attractive force between each other. And he even quantified it. He said that the force is proportional to their masses, and it's inversely proportional to the square of their distance. This was in the 16th century a very successful theory of gravitation. It explained why planets went around stars. It, I think quite apocalyptically explained why apples fall to the ground, etc. But Newton himself actually really worried about one thing. He really, and in fact, this didn't begin with Newton. The ancient Greeks, Aristotle even worried about this thing called instantaneous action at a distance. How can this object here in the sky and this object there, which are thousands to millions of kilometers apart, influence each other? How do they know about each other and feel these forces? So this remains sort of an unsolved problem for several hundred years until the next hero of gravity came along, and that was Einstein. And Einstein said, forget about all of this force stuff. That's not the right picture. Einstein gave us a picture of gravity that was really revolutionary and remarkable. Einstein said, all of the universe is a cushion. You can think of it as a stretched membrane, if you like. It's a cushion. And when you have a massive object, so imagine you have a cushion and you put a bowling ball in the center of that cushion. What happens? The cushion deforms. It distorts. It makes a little dent in the middle. And now if you put a little playing marble at the edge of the cushion, what's going to happen to the playing marble? Well, it's going to follow the curvature of the cushion and fall into the bowling ball. If you took that same playing marble and you gave it a little bit of velocity, it would just go around and around the bowling ball at a fixed orbit around it. And that was Einstein's picture. Einstein said, you don't have to think of this as a force. Think of all of space as a cushion. When you put massive objects there, space gets distorted or warped. And because of that warpage, other massive things get attracted to the thing that warps space. So I study warped spaces, hence a little evil. Okay? And what I look for is little waves. So if you now take that bowling ball you put on the cushion, and instead of just letting it sit there, what if you were just able to bounce it up and down? Then the surface of your cushion would get little ripples, and your playing marble that's sitting far at the edge of the cushion would get wiggled up and down as the ripples went by. And that's what I study now. We look for these gravitational waves from distant objects like black holes, which we can't usually see very easily using light. And the way that we do it is we shine laser beams at mirrors, and we watch those mirrors get wiggled by the passing gravitational wave. That's what we do. And so that's my work. There's Amy. Does that make more sense now? Got the bowling ball. Okay, cool. Okay, now let me tell you why this is so crazy. Okay, so the question to ask is, if I do have a black hole out there, and this black hole is doing a dance around another black hole, for example, and I'm looking for the gravitational waves for it, how much will my mirror move here on the Earth? And the answer is, for the kinds of black holes that we are interested in looking at, or other kinds of stars, our mirrors are going to move by 10 to the minus 18 meters. So that's about 1,000th the size of a proton. Okay? So what do I do for work? I shine laser beams 4 kilometers down in the desert, reflect off a mirror, measure the light travel time, and try to see that if a mirror moved by 10 to the minus 18 meters. Okay? Does that sound a little risky? So, yes, and how did I come upon this? I was in graduate school, and I actually began my work in graduate school studying something far more sane. It turned out at one of these life vicissitudes that my advisor in graduate school was moving his group away from Boston to Chicago, and I didn't want to go. So he suggested to me to go visit with a man who then became my PhD advisor. His name is Ray Weiss. And I interviewed with Weiss, and he told me about this project that he was just starting to work on, which was to directly observe these gravitational waves, which have never been observed before. And he told me the same number I just told you. Well, we're going to shoot these laser beams, and we're going to shoot them down for a few kilometers, and we'll see if the mirrors move by 10 to the minus 18 meters. I thought the man was nuts. And the next day, I joined his group. So that's how the most important piece of my career, which is the search for gravitational waves, began. Really quite by accident, and mostly because I must have some sort of addictive personality, because I could not imagine not going after something that was so amazing. And we're still working on it. 20 years later, we still have not seen directly these gravitational waves, but you'll be amazed to hear we do have mirrors hanging out 4 kilometers away from our lasers, and they do move by no more than 10 to the minus 18 meters. So all we have to do, what we're doing now is we're waiting for nature to give us a strong enough gravitational wave that we'll see it in our detectors. There's a fair bit of fortitude and an enormous amount of luck involved in these endeavors. Okay, so let me come back to my time in graduate school and in Weiss's lab. So I joined that lab quite by accident, and then I found something quite remarkable, which was that this group had an unusually large number of women graduate students, which was we were 2. But believe me, this was unusual because most groups at MIT at the time had 1 or none. So we were a very woman-intensive group. Okay. And it turns out that that was not an accident. My advisor, Ray Weiss, was one of the champions of being sort of very supportive of who you were, and all that mattered. And to this day, I know him. I see him almost every day. To this day, it doesn't matter to him, what you do or who you are. It's just about being a good person and being a good scientist. So he was a good guy, and that taught me something important. So maybe 3 years after I started in his group, I met a woman. Until then, I didn't think much of my sexuality or what gender I preferred. I'd had boyfriends until the time. I met a woman, and I fell in love. And it was sort of because I was, coming of age in this lab where everything was okay. It was a no-brainer. I had very little trouble coming out. In fact, there was nothing even said much. My partner just started showing up at the lab. I used to spend something like 16 or 18 hours a day there. So, some of my life was conducted in the lab, and so my partner started showing up there. And organically, I sort of just came of age as a lesbian in this group, and further out into the circle of physicists at MIT. And so, at least for me personally, my coming out story with work was pretty much as good as it gets. Now, here comes the question of calculated risk. I think I knew all along that it was going to be okay because of everything I had already seen in this group for women. And so there's some training that comes from being an outsider of one kind or another that gives you insights into how the next outsiderliness is going to go. And that's another thing to sort of, build on your life's experiences. That, we're outsiders in many different ways, and we can build on the things that we learn from being one kind of outsider and how to gauge that for the next thing that happens. So that, in fact, was a very calculated risk, although I don't think at the time I was calculating very hard. I was too madly in love. Okay. All right, so that sort of is my story of coming out at work. The rest of my career kind of went the same way. I graduated from MIT. I became a postdoc at Caltech, and I was very clear by then. So by then, that was sort of, I was with my partner for 3 years, and somehow already knew how to navigate things like human resources. Before choosing to go to Caltech, I only checked 2 things before I decided to accept a postdoc at Caltech. The first thing I checked was, do they have good squash courts? And then the second thing I checked was, do they have same-sex partner benefits? And the answer was yes to both. This was in 1997, 96 at the time, and there we were. I then returned from Caltech to MIT to join the faculty in 2002, and I have to say I've sort of been active in sort of student issues since the time I've been back at MIT. One of my experiences when I was a graduate student there was that as a person who was sort of coming out and very comfortably an openly gay person, there weren't many resources at MIT at the time. In fact, all of my social world came from my my partner's world, who was actually a law student at Northeastern. So the law students had a much more organized sort of LGBT group, and so that was my social world. So that was something that was very important for me to see change at MIT, and it really, really has. We now have a full-time LGBT coordinator and a very active set of student groups. We're not doing so well as yet, certainly at MIT, on openly out and active in the community faculty. So, you know, I know many more than are involved, but it's still a very, you know, can count them on one hand, the people who are actively involved. So for those of you out there who are looking for role models, find your faculty and invite them to come to your events until it becomes part of their everyday life to do so. Okay, I want to also talk a little bit then about STEM and how amazing it is to be here in this room at this event. So in 2000, I was working on one of my laser and mirror telescopes, which is just outside of New Orleans. So, and a friend of mine who lives in Chicago happened to be in New Orleans for the MLA, which is this very big annual meeting of the American Literature Society. So she is a literature professor. She studies 18th century drama. You can imagine we have a lot to talk about. But I adore her. She's been my friend for many, many years. And she said, oh, you're in New Orleans. I haven't seen you in a while. Why don't we get together? I am going to the Gay and Lesbian Caucus of the MLA. I scratched my head and said, what could that be? So sure enough, I met her, and I was fully expecting we would go to some small little meeting room, and there would be, you know, 5 or 10 people there, and we'd socialize and have a drink, and that would be it. So she met me in the lobby of the big conference center, and we went to this room, and there were about 200 people there, and they were all sort of, you know, milling about, and everybody had drinks, and everybody was chatting, and that was the Gay and Lesbian Caucus of the MLA in 2000. And I was amazed. I thought this was sort of incredible that this could happen. And I never, ever thought anything like this could happen in my field, certainly, but in STEM in general. And, you know, my feeling about that really was that, well, you know, the feeling of people in STEM is, if you're a scientist, surely you're just a robot or an automaton. You can't have a personality, and certainly you can't be thinking of sex. So I thought, okay, you know, this is another world. I'm really glad to have friends through whom I can access it. Remarkably, this year at the March meeting of the American Physical Society, which is the biggest meeting of physicists, there was, for the first time, an invited session on LGBT in scientists, physicists. And it was well attended, and I actually met a young man somewhere in the room here who was one of the organizers as well. There you are. Oh, wonderful. So I myself couldn't be there, but I was just amazed to see that this had finally happened. And I'm told the attendance was good. I imagine if there had been wine and cheese as at the MLA event, it could have been even bigger. But in the meantime, this was very good. So I am really, really thrilled that events like this one are happening, and that our national societies are starting to wake up to the fact that we are not just robots and automatons. And finally, we're sort of getting around something that I have noticed in my professional world as our very own don't ask, don't tell policy, which is you can be whatever you want to be, we just don't want to know. And in fact, it turns out we are more than just, you know, our lab work and our great ideas. So it's very important that you be yourselves in your workplace. It will make your workplace more fun, and it'll make you more fun. Okay, so my final remarks are actually on something that I sort of have really found to be one of the most important messages in my recent life as I live it. And that's actually a quote that is attributed to William Butler Yeats, but I think it might even precede him. And it says, "Education is not filling a bucket, but lighting a fire." Okay? And I see myself as not just an educator. I see myself at both sides of this quote, as someone who's always learning, but who also in my professional and personal life, I'm also teaching. And so I wanted to spend the last few minutes with you talking about that piece of it. What do we do as scientists and engineers that is constantly helping us learn and teach and serve and mentor? So the words that sort of come to mind for me is that the most important thing is sharing fully of ourselves in our science and in our workplaces and in our schools. And what does that mean? So we're usually just seen as objects that carry knowledge and ideas, and we should share those. You know, my students share their ideas and knowledge with me. I try to do that with them. And I think that's wonderful, but that's a pretty incomplete picture of everything that we could be doing as scientists and engineers. I think there are many other things that we have to share. The most important of them is our compassion of celebrating, knowing who we each are and celebrating our differences, and our time. It sort of turns out that that's the thing we have the greatest shortage of in the lives we live right now is time. And so taking time out to share of ourselves more fully as people doing science and engineering is very important in my opinion. The final thing I want to talk about is role models, because that's a very important piece of how we all get our work done, whether we work at universities or in industry, whether we're students or teachers or parents. So as Amy mentioned, one of the very embarrassing things that happened in my life about 2 years ago was I got a phone call. And the phone call said, "Hello, this is Dan Sokolov from the MacArthur Foundation. I'm calling about a private matter. Are you alone?" So I thought, is this some sort of prank call? What's he going to say next? So I said, yes, I am. And then he told me a little bit that he administers the MacArthur Fellowship. And so I thought right away, he's calling me for a recommendation or reference for someone who's been nominated. And that happens to me, not from the MacArthur Foundation. It happens to me occasionally where I get a phone call like this. So I was like, so he said, I'm calling about one of the recipients. So I said, sure, I'll help you in whatever way I can. So he sort of beats around the bush. He says, this is someone I think you know quite well. I said, oh, great, then I'll help you even more. And then he says, well, I'm calling to tell you you have been the recipient of a MacArthur Fellowship. And I almost hung up. I thought the guy was really just, a prank caller. I thought, what a mean prank. This is one of my friends or someone. Who else could come up with this? But anyway, he told me three things would happen in the next 3 days. So it turns out recipients learn about a week or 10 days before the actual announcement comes. And so he predicted 3 things would happen, and all 3 did. And then I started believing, okay, maybe this is true. The first thing that happened was a letter arrived. The second thing that happened, a photographer arrived. The third thing that happened, a filmographer arrived. And I figured, okay, this is probably real. Now, so then I went through, several weeks of great embarrassment, but it was also a great honor. Why did I tell you this story? Because I want to tell you what came out of it. So as a result, after the announcement was made, my email box and my voicemail box filled up with messages. So more than 500 emails just on with subject title that either said congratulations or MacArthur came into my box in about 2 days. And a small fraction of them, maybe as little as 10%, but that's still about 50 or 60 emails, were from former students and postdocs of mine. And the most remarkable thing that they said was they didn't just say, oh, congratulations. They said things like, you have made a difference in my life. you have been a role model to me. And I really scratched my head about this because I felt like, but I've done nothing. I've just been myself. And so the lesson that I learned from this, and I've been around the country lecturing, and I've met many of the people who wrote to me, is that this is an incredible privilege. But what really has happened is that I've actually managed somehow unwittingly to make a small difference by just being myself. And I want to leave you with that thought, which is that, you know, we make choices that we think are only affecting us, and we make choices about how we spend our time. We make choices about how we live our lives, who should know about different pieces of our lives, and who shouldn't, and who cares and who doesn't. But all of it matters. There are people around us all the time looking, and in small ways, if we can make a difference, what could be better? So thank you all very much for having me here today. Oh, no.